Okay, we've been talking about adding and subtracting decimals. Now we're going to move on and talk about estimating products. Products means to multiply, and estimate means to round. So, if you are told to round to a certain place, you are going to underline that digit to be rounded. Then you're going to look at the digit to the right of that place to determine whether you round up or stay the same. If the digit is 4 or less, the underlined digit remains the same. If the digit is 5 or greater, you add 1 to the underlined digit. After rounding all place values to the right of the underlined digit, they go to 0. So, for example, 52 and 7/10. If we're rounding to the 2, which is the ones place, we look at the 7, which is behind it. The 7 tells the 2 to go up 1, so our answer becomes 53. Or, if we have the same number and we're rounding to the tens place, which is the 5, we look at the 2. The 2 tells the 5 to stay the same. Everything behind it goes to a 0, so we get 50. Two different ways to remember this. 4 and below, let it go, which means leave it alone. And 5 and above, give it a shove, which means you make the underlined number go up 1. Another way to look at it as bullies and angels. 4 and below are angels. They fly away and leave everyone alone. The number doesn't change. 5 and above are bullies. They push the number in front of them to make them go up 1 and then run away so they don't get caught. So let's practice. A is 8 and 7/10. So we look at the number behind the underlined digit, which is the 8. The 7 is 5 and above, so it tells the 8 to go up 1. Everything behind it goes to a 0. B, 2 and 86/100. The underlined digit's the 8, so we look at the 6. The 6 tells the 8 to go up 1, so it becomes a 9. Everything behind it goes to a 0. Everything in front of it stays the same. We don't mess with it, we don't change it, it stays the same. So, work on C, D, and E on your own, pause it, and then come back to check your answers. Okay, so let's check your work. On C, the 3 is underlined, so we're going to look at the 2. The 2 tells the 3 to stay the same. Everything behind it goes to a 0. D, the underlined number is 0, so we look at the number behind it, which is 6. 6 tells the 0 to go up 1. Everything in front stays the same. Everything behind goes to 0. And then E, the 0 is underlined, so we look at the 9 behind it. The 9 tells the 0 to go to a 1. Everything in front stays. Everything behind goes away or goes to 0. So these are our rounded answers. Now, let's do some real-world estimating. The record for the greatest distance traveled on a skateboard in 24 hours was set in a recent year by James Peters. He traveled about 7 6/10 miles per hour. So, we need to see what does 7 6/10 look like on a number line. So we have our number line here with our 7 and our 8. Halfway would be 7 5/10. 7 6/10 is just slightly over that, so you can see the blue dot represents that. So we look which whole number is closest to. Is it closest to? It's closest to 8. So we would round to 8. Also, we can look at the 6. The 6 is 5 and above, so that tells us that we would round up the 7 to 8. So, using that information, let's estimate how many miles James Peters traveled in 24 hours. So, if we estimated it was 8 miles, we would then multiply that times 24 to get our total number of miles in 24 hours. So 4 times 8 is 32, carry the 3, 2 times 8 is 16, 17, 18, 19, so it was 192 miles. Now, do we think that our estimate will be higher or lower than the actual distance? And why do you think that? Well, since we rounded the 7 6/10 up to 8, that means it's slightly above the actual miles per hour. So that means that we should have a higher estimate than our actual distance. Continuing on with our record, we have a new record that was set later by Ted McDonald. He traveled about 10 1/10 miles per hour for 24 hours. About how much further did Ted McDonald travel? Well, we remembered that Peters traveled 100. Sorry about that. We know that Peters traveled 192 miles in 24 hours. So if we estimate 10 1/10 for 24 hours, 10 1/10, we would round to 10 because the 1 tells the 0 to stay the same. And then we multiply that times 24. We get 240 miles. So now we can take those and we can subtract and find out how much further. So 240 minus 192. This becomes a 10 because we're borrowing from the 4. 10 minus 2 is 8. Can't subtract 9 from 3. Borrow again. 2 becomes a 1. The 3 becomes a 13. 13 minus 9 is 4. And we find out that he went 48 miles further. So let's work through a couple examples together. We are going to estimate by rounding to the nearest whole number. So if we're rounding to the nearest whole number, we first need to underline the digit we're rounding to. So for A, that would be the 9 and the 1. So we look at the numbers behind it. The 6 tells the 9 to go up 1, so we make it a 10.0. The 8 tells the 1 to go up to 2, and everything behind it goes to 0. Now we can multiply. 10 times 2 gives us 20. Let's look at B. Rounding to the nearest whole number, so that would be the 4 and the 3. So for the 4, we look at the 2. The 2 tells the 4 to stay the same. Everything behind it go to 0. The 1 tells the 3 to stay the same. Everything behind it go to 0. So 4 times 3 is 12. Now, I want you to go back to your Google form, and you're going to do the next 4 as your exit ticket.